Now, unless you've been living under a rock, there's just one word, two letters that you've been hearing all day, right from your social media to news outlets, from your schools, local communities, all the way in your corporate life. And that is
AI, generative AI.
AI, artificial intelligence. Artificial intelligence.
AI. It uses AI to bring AI.
Most people think learning AI is just calling an API or asking ChatGPT or Claude to write the code for them. But if you actually want to build and learn the next generation of tech using AI, you need a map to know which part do you go to, why. The why is very important. So I spent months building a repository that just crossed 3500 stars on GitHub, and today I am breaking down the exact 10 module path that takes you all the way from hello world to building the latest agentic AI systems. Look, the world of AI is moving so fast it gets exhausting at times. That's why you don't need more resources. You just need the right resources in the right order. In this video, we're going to go module by module through the entire AI ML roadmap from scratch and even the new world of AI agents and everything. So whether you're a student or a self-taught developer or you're already with 10 years of experience in corporate but you want to dive into the latest AI world, this is your 2026 survival guide. Let's get started. Hi, I'm Aadith Sukumar. I'm an AI ML engineer and I did my undergrad in BTech in artificial intelligence and machine learning with specialization in security and privacy. My core areas are into artificial intelligence, cybersecurity, and my research. I just love combining them together and understand what is truly fascinating about this field. So let's get started. If you want to know more about me, you can definitely access my website, my LinkedIn, everything will be in the description. Let's get started with the module now. So before you can start flying, you need to learn how to make the engine. So that's where module 0 comes into play. First up, the most important is Python. AI runs on Python. You need Python to run various libraries, to load data, to train models and everything. So first thing, the programming language is going to be Python. Second thing, where do you code? Where do I build? That's a good question. For that, you need an IDE. And the most common one, the most popular one that everybody knows is VS Code. Obviously, Cursor is out there in the market. Cursor is there for all the agentic AI features wherein you can just give a prompt and it writes the whole program out for you. But in my opinion, you can get started with VS Code. It's the most common, most popular, versatile. It has a tons of plugins and themes and various features. So I would recommend go to VS Code. You can go to the website, give a quick Google search, and based on your operating systems, whether you're running Windows, Linux, or Mac like me, you can get things installed right away. And it works in a jiffy. Module 1 is where most people quit. The math behind it all. See, you don't need to be a professional mathematician, but if you don't understand basics of linear algebra, calculus, and probability, you're just a script kiddie. You don't know why a model is failing or why a model is working. You're going to go back to ChatGPT and Claude every time there's an error because you actually don't know, wait, how is an AI system working? It should never be a black box. You should understand why something is working. So to kick things off on it, I always recommend 4 main topics. 1, linear algebra, probability, calculus, and statistics. Now over here, probability and statistics are something I would give utmost importance to because that literally dictates how everything in AI works. You think everything is a probability? Highly yes. For an AI, everything is a probability. If you ask a question to an AI like, hey, what is the capital of India? It has multiple answers in its head. It could be Mumbai, it could be New Delhi, it could be Paris, it could be New York. But for it in its brain, New Delhi has the highest likelihood probability. That's why it says the answer that, hey, I think the capital of India is New Delhi. That's how it all works. It's all probability at the end of the day. Linear algebra and calculus, even though you might not see it deeply integrated into AI, it's the core of how various AI models are built, how they actually function, because there's a lot of loss functions behind it, how it works, how it does not work, how it's technically built or mathematically constructed to give certain outputs. That's why these two are very important. Now, there are 5 main modules that I've made over here. One is a playlist, the Math for Machine Learning playlist, NPTEL SWAYAM Discrete Mathematics course, Discrete Structures via Sailor Academy, Linear Algebra lecture series from MIT, Fundamental Math for Data Science. Now if we come back over here, I definitely recommend the NPTEL SWAYAM Discrete Mathematics course because the main thing over here is it is widely used, it's very popular, and there is a particular exam for it, so you actually feel completely into it to studying. You won't feel skipping it because there's a proper start date, end date, enrollment exam for everything, and it has 3 main categories, and there's a 12-week complete course that are instructed by the top professors at IIT. Obviously, if you're not into a course, but if you want to go for a playlist, then I would go for the Math for Machine Learning playlist by Weights and Biases, which I recommend. It has 7 videos that are about 40 minutes long, but all of those videos are super amazing. You can start one by one from the Math for Machine Learning, jump on to linear algebra, go to calculus, and then eventually probability, which is one of the best videos out there. I highly recommend it. I've watched all of it, and I truly love Weights and Biases, and the way they teach is very, very intuitive. So that brings these two done. Now, let's say if you want to do more lectures or course, then I definitely recommend the MIT lecture series on linear algebra. There are lots of lectures and it's all downloadable videos that you can bring. They also provide a set of examinations that you can provide. So it's all self-learning. Honestly, I would recommend you to be very honest with yourself, not cheat and look at answers directly. But the MIT courses are very, very knowledgeable. They go super in-depth and they really help you understand the course. Then comes phase 2, that is building your foundation. Now, the math is in your back pocket. We've hit module 2, that is proper Python. It is technically the lingua franca of AI. Don't just watch videos. You need to use the HackerRank links in the repository to get your hands dirty, because you need to actually try and build Python. That's how it works. So the main thing over here is Python programming. You need to learn how libraries work. You need to build functions over there. And you need to learn how to run Python. That's why you can open up VS Code, write up a quick Python code on Hello World, see how Python is working. If you do not know programming in Python, then building AI models yourself would be a bit difficult, as well as integrating them, unless you use some sort of a low code, no code tool that you have. Now, what exactly over here I'm focusing on working with libraries is because you're going to be dealing with a lot of libraries in machine learning on in your AI roadmap. This could be something like NumPy or Matplotlib or just pandas to get things rolling. So over here in my repository, you can see the packages.md file. Over here, I've added all the various libraries that you have, how to install them if you have pip installed, and then each of these libraries. For data science, the most recommended is NumPy, Pandas, Matplotlib, Seaborn, and SciPy. Then comes machine learning libraries, then computer vision libraries. I'll come to all of these in the modules that we have in the description. But then one quick installation is you can do a simple library name installation. And it's not just these libraries. For any libraries, you need to learn how they work, how can you import them instead of writing 10,000 lines of code every single time. And I've obviously added a lot of additional resources and documentation as well. So if you truly want to understand how something is working, then you can quickly go to the documentation and user guide and see exactly how it is built on. Moving on to a super important module, data science. They say data is the new oil, and they are so right. Now imagine you're building a stock market predictor for Nifty 50. Before you can use AI to predict, hey, what should I buy today or tomorrow? You need to first clean the data, handle the missing values, and understand the trends. That's where data science comes in. It really helps you understand the data truly. You need to understand why your data is a certain way before you can actually start building on it. So the key modules for data science is first dealing with numbers. If you just have floating numbers everywhere in your artificial intelligence coursework, you're never going to understand truly how and why and what are you building exactly. Then you jump on to structuring data. Okay, I just have a bunch of numbers scattered everywhere. I need to put them into structure so that I can process it, read the outputs, and so on. Then comes data cleaning. I've structured it, but then there's so much unnecessary junk data that I have, or there's some missing data. And if there's any missing data or biased data, then your model will also be equally biased. Remember, artificial intelligence is called artificial intelligence for a reason. It all depends on the data you built in the backend. So if your data is not right, chances are highly likely your model is also not going to be correct. Then comes data visualization. I already explained to you the two main modules that you had, let's say Matplotlib and Seaborn, that is used to visualize the data. Because hey, again, what do you just see in numbers? You need to show them in pie charts or bar graphs or trend lines. It could be interactive lines just to show prediction. Now let's say in the example I provided, you're building a Nifty 50 model, right? So to predict where a particular stock is going, you can just say, okay, these are the numbers, these are the numbers. But imagine if you show the same thing in a plot wherein you show, okay, for so long it has been at this range, but then in the next seven days, the predicted Nifty 50 price could go all the way over here. And that really speaks a lot of volume because you actually understand and you see the data. If you can measure it, you can manage it. And the most important courses for these are, one is there's a YouTube video on a quick 5-minute intro to data science. Then let me quickly go back over there. And then you get the data science overview. A very good recommendation is the Python for Data Science YouTube video that is there. This is by Free Code Camp. It's a very long video, but it actually dives through the depth of how everything works. And this is a video I truly recommend. However, if you are not willing to go for videos, if you want a course to go with, then you can go with the IBM Data Science course. This course is a free course that you can enroll at any time. It's also part of a 12 course series that you have. And then this has a complete certification course starting from what is data science, how to use it. They also have projects, how to deal databases, machine learning, applied science and everything. And at the end, you get a career certificate that you can add to your resume, which is super, super useful. So I genuinely recommend going for the IBM Data Science Professional Certificate. I've also done this as well. And I really found the courses and the modules very, very interactive, intuitive, and it goes very simple, and then while also covering complex topics. Then we come to the main game, the heart. Module 4 machine learning is the heart of everything. This is where we actually teach machines to learn from patterns without explicitly coding the rules out. Very simple. Let's say there's a child. How do we teach a child what is a cat, what is a dog? We show pictures of cat and be like, hey, this is a cat, this is a cat. Then we show pictures of a dog. The next time, if I just show a picture to the child will automatically try to realize, wait, this looks like a cat, or looks like the other photos that I saw previously, which was called a cat. So I think this is also a cat. That's how children recognize patterns. That's how they recognize various shapes, various objects, and so on, and even people. And that's simply how machine learning is based as well. Think of it as a child. It's a child that does not know anything. You need to show clean data. You need to teach it what everything means so that the next time the machine learns and also gives output itself. Over here, it has core modules in supervised machine learning, unsupervised machine learning, feature selection, and model evaluation. Why this is important? The supervised and unsupervised machine learning are two main fundamental branches. One deals with labels and deals with labeled data. The second is unlabeled data, wherein you don't have any predefined labels. You need to find it yourself. You cluster into groups. Both of them have their own separate use cases. And no matter if you have the use cases, the most important is feature selection. That is phase 3 over here. Feature selection is more important because you need to learn what are the primary features, ignore the other features, and also understand what is the feature you actually want to predict and get going on. And obviously, model is built, everything is working fine, but how do you figure out if your model is correct or not, or how accurate is your model? That's where model evaluation comes into play, wherein you use accuracy, recall score, precisions, F1 score, or various scores, or various metrics to understand how good your model is. So these are some of the important topics that you need to learn in machine learning, and some of the courses for it. I definitely recommend one course above everything else, that is the Harvard X Data Science for Machine Learning course. This course is actually very amazing. It's Harvard X certified, and it does not require any prior experience. It's self-paced. It takes about 5-6 weeks to get through this course, but all the overview of it is pretty amazing, and plus the certificate is also very strong. So I would recommend that. Apart from that, you also have a lot of courses where you can go exploring Azure with OpenAI. There's a machine learning specialization by Andrew Ng. I'll come to that in the end. And then the machine learning path using Google Cloud. So these are some of the things I would recommend. Now, the fifth module, the machine learning specialization by Andrew Ng. This is considered like one of the top tier or like the holy grail of learning machine learning. This is very, very complex, very in-depth by one of the most famous AI visionary, Andrew Ng. And this is a course I would recommend if you're really technically interested in learning machine learning, and not only learning but actually mastering machine learning specialization. So this is a 3-course series that will be covering supervised machine learning, advanced algorithms, and unsupervised learnings. And these 3 courses are combined close to about 90 to 100 hours. But this is one of the most amazing courses that I've seen when you want to learn machine learning. So I highly recommend that if you're really technically into machine learning, and if you really want to make a career out of machine learning, this is a must do. I need to pause you right there just to ensure that you are on track with me, because that marks the end of part 1 of this video. I've deliberately cut it down into 2 parts. Part 1 being a very easy to follow, the beginner foundational steps, with part 2 covering more advanced concepts like generative AI, reinforcement learning, agentic AI, and much more. So I want you guys to take a breather over here, try to grasp all the concepts. And if you've already finished watching part 1 and you're ready to watch part 2, then it's gonna drop just in a couple of days. So do follow me, do subscribe over here, and I'll drop part 2 very soon so that you can learn much better. But until then, if you have any doubts, always feel free to go reach out to me down in the comments or in my email, or you can go to the GitHub repository, reach out to me there as well. I hope you really loved watching this video so far, and it was very insightful and helpful to you. Even if it helped you one person, that's a great success for me. So I'll see you guys very soon in part 2.